This is Algebra 1, 2.4. We're going to solve equations with variables on both sides now, or on each side. So that means the biggest thing about this is simplifying each side if you need to, and then bring the variables to one side, the numbers or constants to the other. At least for these ones. Eventually, as we stay with this longer, it's going to get more difficult as we go on in the book. So, what you can see is that we have a single variable, k, but that k is on both sides. It's on the left and it's on the right. So we need to get them on the same side. Now, my general rule of thumb is to move the smaller variable coefficient, or the one with the smaller coefficient. So, what's smaller, 5k or 3k? Especially if I'm talking about money. If I'm going to give you 5k or I'm going to give you 3k, which one's smaller? 3k. 3k is smaller. So guess what? I'm going to move or transfer the 3k to the other side. And when I do that, since it's adding 3k, I need to subtract 3k. I'm going to subtract 3k from both sides. Now, why do I move the smaller variable? It gives me a greater chance of keeping my variables positive. And I like to multiply or divide by positives, that's why. And so, they're gone. So 2 plus, what's 5k minus 3k? 5k minus 3k. It's 2k. Equals negative 6. And now, it just becomes a problem that we just did in the last section. To get k's by itself, I will subtract by what? Subtract what from both sides? 2. So they're gone. So 2k is equal to, what's negative 6 minus 2? Negative 8. You are $6 in the hole and you borrow another $2, you're now $8 in the hole. And to get k by itself, divide by 2. And so k equals negative 4. Of course, you should always do what with your answers? Check them, so please do. Remember, you cannot, when checking, go across the border or across the equal sign or the wall. So therefore, you stay on the left side, or you stay on the right side, and then you look at each other and say, are we the same? Yes, it's good. No, that's not good then. Any questions on that? So what happens if they kick it up a little bit? And they give you something like this. 6 times the quantity 5m minus 3. And 1/3 times the quantity of 24m plus 12. Now that's a little scarier. But here's the thing. Just because I have something outside of parentheses, there's usually a couple different ways. For us right now, maybe the easiest way to deal with this, take the 6 and the 1/3 and distribute them into their respective parentheses. So take the 6, multiply it to 5m to get what? 30m. Multiply it to negative 3 to get negative 18. And what's 1/3 times 24? Or what's 24 divided by 3? 8m. And what's 12 divided by 3? 4. And now this one turns out to be a problem that we just did. So you ask yourself, which one's smaller, 30m or 8m? Which one's smaller, 8 or a 30? 8. So I'm going to move it. So I'm going to subtract 8m from both sides. Now, last time I did this, and then I rewrote it, and then did it again. If I move the variables from the one side, that means I need to move the constant from the side that I'm putting the variable on, so this side. I want to get rid of the 18 as well and move that to the other side. So instead of doing this in 2 separate times, can I do it now? Can I go and say, hey, how do I get rid of a negative 18? I add 18. But what I do to one side, I have to do to the other. So therefore, I should be canceling something on both sides. And what's 30 plus a negative 8, or 30 minus 8? 22m equals 4 plus 18, 22. Divide both sides by 22. M equals 1. Check it out. So this one I think is the last example. This one has some grouping symbols in it. Some things that we possibly want to combine on one of the sides before we start to add and subtract from both sides. So again, simplify each side first before you start to bring stuff around the corner or the wall or the border here or whatever you want to call it from one side to the other. So that means take the 3 and distribute, which means as well that I am not going to do anything with the left-hand side, leaving it. What is 3 times 5? X?
15.
15x. 5 times negative 4.
12. Negative 12.
That's a 3, sorry, not 5 times, it's 3, so that's negative 12. And guess what? Minus 10x goes along with the rise. Not doing anything to it yet. The left-hand side of this thing is still ready to go, but the right-hand side's not. It's not because I can gather like terms. What's 15x minus 10x? 5x. So 5x plus 5 equals 5x minus 12. Now what do we want to do? Get the x's on the same side. Which one's smaller, 5x or 5x? They're both the same, so it doesn't matter, right? Just subtract 5x from both sides. Gone. Wait a minute. 5 equals negative 12? When does 5 ever equal negative 12? It doesn't. What does that mean again? It means something. We said that meant something a while ago. No solution. No solution. 5 will ever equal negative 12. 0 will never equal 2. All of those things, right? What happened though? What would happen? What happens? I'll change colors. What would happen if it came out to 2 equals 2? Then what would that mean? Side note here. What would this mean at the end? All real solutions, right? Or infinite many. So if you get 2 equals 2, infinite many solutions. If you get 2 numbers that don't jive together, that means it's no solution. And if it's x equals 5, then there's one solution, it's at 5.